Hello and welcome again to Object-Oriented Application. My name is Ajay. Next one, what we're going to talk about is UML. Quite a interesting topic. UML stands for Unified Modeling Language, used by technical people to A, understand what a system is going to do and what is it doing, and B, to create documents and artifacts which will help other people understand how things work in a system. It's both a combination of technical and non-technical stuff. Technical because it requires you to know specific notations and specific terminologies that you should be using while working on UML. And non-technical because you have to basically understand why are you using UML and what is the problem domain that you are trying to explain. It's a combination of both technical and non-technical stuff. Like I said, UML stands for Unified Modeling Language. It's a graphical notational language. Although it is a language, you don't actually write code or anything of that sort. But it's a special kind of language considering that it's full of drawings, graphical notations. So anything that you want to explain is represented using a diagram, some kind of graphical notation, and that becomes its own language. So it's a graphical notational language which uses object-oriented methods to express all the aspects of a system. So it's a process flow, interaction between objects, interaction between systems, how is the environment, servers, and how do components talk to each other, various validations, conditions to be checked, and so on. Everything is represented in a notational manner to explain what the system is doing. UML is basically a combination of object method technology, which was a concept that was created by certain very highly technical and very good technical people quite a few decades ago. So it's a combination of OMT and Booch. Booch was the method created by Grady Booch. OSE stands for Object Oriented Software Engineering, which was created by Ivar Jacobson. So these three methodologies were combined and they came up with something known as UML to make it a standard, because all three technologies, or rather all three methodologies, were doing the same thing, but they had their own different way of representing stuff. So instead of confusing people by having different notations and different ways of doing the same thing, what they said is, let's come together, create a common platform where anyone who wants to do anything related to design will use a common platform, and that's where UML came into existence. It is a recognized object management group standard. OMG is a group which takes care of anything related to object management, UML and all that. So it's a recognized standard. When we say it's a recognized standard, what this means is that if someone comes up with a tool which says using this tool you can create UML diagrams, what it basically means is it meets all the standards that are specified by OMG for UML. So it provides everything that any standard UML technology or UML concept that is to be explained, it meets those standards and is understandable by everyone. UML can also be used to establish a very comfortable dialogue between the user and the system developer. Most of the times what happens is users are not technical people, and technical people, that is developers, are not good at expressing themselves verbally or anything of that sort. So they are not good at documentation. These UML, what they do is they represent the working of a system in such a way that it is quite easily understandable by both technical as well as non-technical people. So it tries to bridge the gap between these two different types of audiences. Different tools available that using which you can create UML diagrams. Visio by Microsoft, Rational Rose by IBM, ADEX by TCS, System Architect, GD Pro, Together J, and quite a lot of them, but Visio and Rational Rose being the most commonly used. We will be using Visio. When I'll show you some demonstrations on how to create these UML diagrams, we will be using Microsoft Visio. Now getting into UML details, when you want to, in our object-oriented previous sessions, we've seen about classes, objects, methods, this, that, and all, and we've been talking about public methods, private methods, protected methods, and so on and so forth. Now, if this is to be represented in a diagram, there has to be certain notation which will identify what is what. Is a method public, is a method private, and so on and so forth. So in UML, the way to represent these scope or access, path of methods or properties is plus stands for public, The hash sign stands for protected and minus stands for private. So if a class is defined, and in that if you see a method name which is preceded by a plus, it means it's a public method. If it is preceded by a minus, it's a private method, and so on. Multiplicity is defined using one of these notations. So if you say 1, it means 1 and only 1. 0 dot dot 1 means 0 or 1. 1 to star means 1 or more. There can be 2, 3, 10, 20, 100, whatever. Star means 0 or more. So there can be either nothing or 1 or 2 or 10 or 50. M dot dot n means it's a range between 3 and 5, between 18 and 60, working people and so on and so forth. So that's the kind of notation you use to define multiplicity between objects. For example, one vehicle can have 2 or more tires. We're talking about generic vehicles as such. So any vehicle will have at least 2 tires, a scooter or a bicycle or whatever. But there can be more. Auto rickshaws have 3, cars have 4, trucks may have 6, and so on and so forth. So 2 or more. So that's how you represent multiplicity. You can also specify associations between various classes and objects. For example, order and order line. Order line basically one order item. So that's how it's a simple association. There can be what is known as an aggregation. A member is part of a trade union. Okay, it is indicated by a solid line and an empty diamond pointing towards the whole. It's basically a whole part structure. What this means is there is a container, a whole, which will have certain parts in it. Container and contained. So the diamond will point towards the container. So trade union has members. So the diamond will be pointing towards the trade union class, and there will be a solid line coming in from member. So that's an aggregate. And there is something known as composition. For example, England has London, or London belongs to England, or London is part of England, whatever you want to call it. So it's a container and containee or whole part, whatever you want. Now the difference is that the association just indicates a normal association between two entities, nothing specific over there. It's just indicating that these two classes are related to each other somehow or the other. The difference between aggregation and composition is that if it's an aggregate, it means the part can exist without the whole, and composition means the part does not have any identity of its own. If the whole is not there, the part doesn't make sense at all. For example, in this case, the member is part of a trade union. But if a trade union does not exist, does not mean the member dies. No, the trade union dissolves, or the member leaves the company and joins some other organization or another factory or another company or whatever it is. So trade union exists on its own, and the member has his own identity which can live without being part of the trade union. So it's an aggregate. Composition basically means if the whole is destroyed, the part is also destroyed. If there is no England, there is no London. Okay, so that's composition. Aggregate is indicated, like I said, with a solid line and a diamond pointing towards the whole, and composition is indicated by a solid line again, but this time the diamond which is pointing towards the whole is a filled diamond. So these are specific notations that you have to remember. You cannot use any other notation to indicate these associations. Inheritance, we've already seen this while talking about classes in our object-oriented concepts, but the way you represent them on UML diagram is basically you will have base class and subclasses or derived classes, and there will be a solid line moving from the subclass to the base class and an arrow pointing towards the base class. So that's how you represent inheritance. Some diagrams that are more often used than any other diagram. There are quite a lot of diagrams that are available in UML, but these are the most common diagrams that you will use in your day-to-day activities. Use case diagram, class diagram, sequence diagram, state chart diagram, and activity diagram. So we will cover all of these one at a time. I will explain the concept of what these are and what they are used for, and then also show you a demonstration on how to create these specific diagrams using Visio. So we'll take them one at a time. Use case diagram. Now, basically, this a full system will have a lot of small functionalities or small features that make the whole system working as one. Now each of these small functionalities or feature or whatever you want to call them needs to be explained individually. Of course, keeping in mind the whole system, but you cannot have a single storyboard which explains the entire system from end to end. You need to break it down into smaller components, smaller parts, smaller modules, and explain each of the functional components separately. And use case is something that is used to identify and explain these individual components and features separately. So it basically illustrates a unit of functionality provided by the system. For example, in online shopping site where you have to first log in so that you can place an order. So the login itself becomes a functionality. So you can create a use case which will explain the login functionality. Then searching for an item, that becomes a functionality. So you can have a use case for that. After searching, you can add a product to your cart. That again is a functionality. One or more items to your cart. Once you're done with that, you need to place an order. So that becomes a functionality. So each of these can be explained individually as a unit by itself using a use case. Now this also helps the team to visualize what are the different requirements of the system that need to come together and make the system work. So basically it helps people identify all such intricacies that go on in the system, and it also kind of gives you a facility or ability to identify the actors without which the individual features or functionalities will not work. When I say actors, it means the people or the group of people who will be performing those actions or those functionalities or using those features. For example, I as an individual is not an actor. I as a user am an actor. In a system there can be different types of users. There can be a guest, there can be an administrator, there can be a registered member, and so on and so forth. As a guest, I can only browse through the site and search. I cannot place any orders. As a registered member, I can browse through the site. I can pick items, place them into my cart, place an order, provide my credit card details, and get a delivery and so on. So as a registered member, I can do that. As an administrator, I can add more products to my basket of categories that I am selling on my website. I can create more categories. I can provide more features. So initially maybe I am providing only credit card based, and then I want to make some changes and provide some other modes of payment and so on. So an administrator is someone who will be able to do all these stuff. So different types of users. These actors are these types of users. So when you are explaining use cases, you also indicate which user, which type of user is going to perform which activity. So this gives a very clear picture as to what all types of users will be able to perform what all types of activities, and what is it that activity is going to do. This also helps you put in place a security mechanism based on role based access, saying these types of users can do only this but not that, and so on and so forth. A simple use case diagram to demonstrate how it is used. So you have actor A and actor B, then there is a system boundary, and all the use case within that system are depicted using an oval shape within the system boundary. So use case X, use case Y, login, place order, these could be sample use cases, and actor A and B are different types of actors. So if I take an example of some kind of a application which is giving loans and so on, so this could be a sample use case diagram for that. There is a customer who can register a loan, who can record a loan return, add reserve a video, or calculate daily earnings is something that the manager will do. A counter staff is someone who will register a loan or record a loan return. So this basically represents a store where, let's say a video rental store, where I am a customer, I walk into the store, I want to become a new member. So I walk into the store and tell the counter staff I want to become a member. So that's the add new member. So that's when the counter staff will open the system and what is your name, your last name, this, that, and address, and so on and so forth, and make me a member. Once I become a member, I can register a loan. So I can take a video, a DVD or something on rent, go home, watch it. I'll come back the next day and return it. So that's the record loan return. So these are different use cases that I can also reserve a video. A new movie is coming up, So I will tell the counter staff that reserve this video for me. It's coming out on DVD next Friday. So I'd like to see it. I'll collect it on next Friday morning. So I can reserve a loan also. The manager of the store will probably log in at the end of the day and calculate what are the daily earnings. So, different use cases and different actors accessing different use cases. So let's take a look at how to create use case diagrams in Visio, and so we'll switch to the demonstration. This is Visio, the screen for Visio 2007, Microsoft Visio 2007, and we will begin with creating some UML diagrams. First of all, use case diagram. So what I'll do is I'll say file, new, software and database, and select a UML model diagram. The first thing I'll do is create a use case diagram. So the first thing you do is create a system boundary. Okay, and let me just increase this to 100% and resize the boundary so that it is visible in one window. Okay, so let's say this is my system boundary, and let me call it my shopping site, or rather online shopping site. Okay, now what all use cases will be there? Drag and drop a use case, double click on it to give it a name. So let's say login. Similarly, you will have drag and drop a use case and say log out. There will be search products. There will be add to cart. There will be place order. Okay, something like this. And then there could be use cases like manage products. So if new products are made available and so on. Another could be manage categories. Okay, and so on. Very simple. Now these use cases can be used by different types of users who are known as actors. So one actor would obviously be a registered customer. Another actor who can do the management part, which is manage products and manage categories, would be an admin. Another actor could be a guest, who is a non-registered user coming to the website. So what all use cases can each of these actors participate in? We take this communicates line, bring it here, and then point it to login. Okay, then take another one, pointed to logout, another one pointed to search, take another one pointed to add to cart, and one more which points it to place order. Similarly, take one, put it from admin to products, and one more will go from admin to categories, and then one more which will be from guest to search products. Okay, I may be a guest, I cannot place an order, I cannot do a login logout, but I can still search for products to see what all products are available on the website. You will also see in this, every time I add a connection here, it shows me end1, end2, and so on. It basically just some indication to give a name to each of these ends. You can remove them. This is specific to Visio. If you do this in Rational, you will not have to remove this manually. So it gets removed. So you can go ahead and remove the end1, end2, end3, end4 from all the lines. So this is basically a use case. You have a system boundary wherein you list all the use cases and then depict all the actors around the system boundary, and then which actor communicates with which use case. What may happen is that your system is so huge that there are hundreds and hundreds of use cases. So you need not create one single use case diagram which depicts all the 100 into a single one. No need. You can break it down into modules, and then for each module you show the use cases that are applicable to that module. So that way you can break down your whole system into small modules and then depict each module as a full use case set. Okay, so that's a use case diagram. So this was for an online shopping site. Similarly, it does not matter what system you are using or trying to create. You create this use case diagram, and based on what actors are doing what, you will come up with your structure and design for role-based access, saying which type of user is allowed to access which type of functionality in your system. So this also becomes an input to your security mechanism on your system. So this is use case. All right, we just looked at how to create use case diagrams using Visio. Just a note that although we are using Visio, there are other tools available, but it doesn't matter what tool you are using, the visual representation and notations remain the same. So whether it is rows or any other tool that you use, the notations remain the same. Now the next diagram is the class diagram. Now this class diagram shows basically in your application you may have lots of classes: customer, order details, product, category, shopping cart, and so on and so forth. A lot of classes that will interact with each other. You will also have some inheritance going on: vehicle, car, BMW, Audi, and so on and so forth. Lots of inheritance also. So you need to represent this using a diagrammatic presentation, and that's where class diagram comes into picture. So UML provides you with a class diagram wherein you can depict different kinds of relationship between classes, that is inheritance, association, aggregate, composition, and so on and so forth. In UML, a class is depicted using a specific notation, which is right here in front of your screen. So if it's a customer class and it has properties and methods, so the properties will be represented, there will be the name of the customer at the top, and then properties in the center, and then name of the methods at the bottom. This is a very simple class with very minimal properties and methods. An actual class will be quite huge. It's not practically possible to list it all in a window. So this is just a sample for you. I just showed you a single class, but then a class diagram is not a single class. It's about many classes and how they interact with each other, or how they are associated with each other. So another sample class diagram for you, where you have a report class, and then that's the base class, and then there is another sales report class which inherits from report, and then this report class has okay, and the CD is for a band. So it basically, a CD is the music CD. We're talking about a music CD here. So on the CD there will be songs and all that by different artists, different bands. So things like best of 2013 famous hits and so on. So it's a CD. So there is a CD, and this CD will have songs from various artists. So it's a many to many relationship between CD and band. And there is inheritance between report and sales report, CD sales report rather. This is a very hypothetical scenario. This is not actual thing. I'm just showing this to demonstrate how a class diagram may look like. We've already seen this about associations, that there can be association. The previous slide was showing you association between a CD and bands. We spoke about this earlier also. I'll speak again that there is aggregation and composition. Aggregation is when the part A can exist without the whole. Member is part of trade union. If trade union does not exist, member does not die. The member has his own individual identity and can exist without the trade union. So it's a aggregate. It's represented with a solid line with a diamond pointing towards the whole. And then there is the composition, where the part cannot exist without the whole. So if England is destroyed, London also is destroyed. If there is no car, what's the use of an engine? Okay, so that's composition. So we'll switch to Visio again and see how class diagram can be created, and we'll see various permutation combinations there, including associations, composition and aggregate. Alright, so now the next diagram is the class diagram, and I'll go ahead and create a class diagram. So what I'll do is I will say insert new page, okay, and or what I can also do is go to static structure, insert new page, and I will say class diagram, and enter. Okay, so go to, and on the shapes I select static structure, which is for class diagram. Now here also I'll change this to 100%. Now what you do is you drag and drop. Every class is represented using a notation which is this. So you drag and drop a class here and then double click on it to give its name. So let me call it customer. Now so it becomes customer. I will also have other classes, for example, or instead of customer, let me make it vehicle. Then I will have car. We've actually seen this, but truck. And then I'll have BMW, and an Audi. Okay, and then add the vehicle. I will say what are the attributes. I will say color, it's of type string, it's private or public or protected. I will say public. Then there is engine type, which will also be a string, and it will be public, and number of tires, which will be an int. This also will be public. I'm not sure why they have put private as a default. It should be public. So that becomes the properties. I could have many more. I can also define what all operations, methods are available in this class. So let's say start. What does it return? Let's say it returns a string. It's a public method. And then stop. Again returns a string. Could be accelerate. It could return an integer indicating what is the current speed, and so on and so forth. Then for each operation, let's say accelerate, I could put properties there which to specify what all parameters are received. So current speed. Okay, I say it's of type integer. And then new speed. So all these things you can do, and I say okay, and the whole thing comes up over here indicating that color, engine type, and number of tires are properties, whereas start, stop, and accelerate are methods, operations. And accelerate method receives two parameters, current speed and new speed. Excuse me, the name of the parameter is wrong. I'll correct it. Should be speed, not speed. Sorry about that. And it returns an integer indicating what is the new speed. So something like this. Now I will not add too many methods and parameters and properties. I'll just indicate focus on the class diagram. So now I have to show the inheritance. That's where you use the generalization notation. Okay, that's how you show inheritance. Solid line with a arrow pointing towards the base class. Similarly, there will be generalization from BMW to car and Audi to car, and so on and so forth. This you can keep doing. Now what may happen is you may have an interface also. So what you will do is you will have an interface. Let's say I call it I aeroplane. Okay, and then you're creating a class aeroplane which implements this interface. So when implementing the interface, okay, when you are implementing an interface, what you do is you take this generalization thing, but since it is an interface, what you do is you change the way this line is looking. So what you do is select this line, go to right click, format line, and change the pattern to a dashed line. So this becomes an implementation. Okay, so that's how you represent an interface implementation. Now this aeroplane also inherits vehicle, so you can do this. Okay, so that's how you represent interface. There can also be associations. Okay, for example, I can have an association here called person or driver, and the association is basically a very simple association between the driver and the vehicle. Okay, what you can do is it's a one-to-one. One driver can at a time drive only one car. So I'll remove this. Multiplicity is one driver, one car. So one driver can at a time drive only one vehicle. So it's a one-to-one relationship. I could have a class called tires, and the association will be one vehicle having one vehicle having 2 to 4 tires. Okay? That's how you represent multiplicity. Okay. Now there is also the aggregate and composition I had mentioned to you earlier. So let's say if I have a class called England and a class called London, I have a class called Trade Union and a class called Member. The association here is that it's a composition between London and England. Solid line with a filled diamond, right? For member, it will be a solid line with a empty diamond, but this is showing a filled diamond. So what you need to do is you need to change the line where you select the end in an aggregate. So that becomes your aggregate. Okay. London is part of England, member is part of union, but member can have its own identity without the trade union. London is nothing without England. So that's a composite and that's an aggregate. So this is how you can, create class diagram and depict relationship between different classes, how they are associated to each other, what inherits from where, what implements what, and aggregate and composition. So that is class diagram. Now moving on, after class diagram, sequence diagram. This is it's much more technical than any of the other UML diagrams. Basically because it represents the flow of a functionality in technical terms. You have to actually represent in the diagram, you have to actually show how different objects interact with each other, not classes, objects, and the actual flow that, and also indicating methods that will be called and what kind of data will be returned from a method and so on. So it gets that kind of technical, which is why sometimes sequence diagrams can get a little bit complicated. But it's basically if a use case explains how an actor interacts with the system and what does the system do in pure English or non-technical terms, sequence diagrams tries to explain the use case in a more technical manner. So it's a use case defines how an actor interacts with the system, but it is also important to define the interaction between the underlying objects of the system. How do they interact with? Which object calls which method of another object? What parameters to pass? What is the return value from that method? And then what process to be done on that return value and so on. And then again, if another method is to be called, then where is that method and so on. So all this also needs to be explained. This is done by sequence diagram. Now this sequence diagram will show quite a detailed flow for a specific use case. So it takes a use case and expands it further and shows interaction between objects. It can show not just one use case. It can combine many use cases and show the interaction of all of them together in one sequence diagram. That is also possible. It's not mandatory that one sequence diagram can show only details about one use case. No, it can be more. Now, these sequence diagrams show the calls between the different objects in their sequence. So first, user logs in, clicks on login, method called to validate user, makes a call to the database, fetches data, and indicates whether it's a valid username and password. If valid, determines what are the roles that the user can perform. Based on that, it will render a UI and so on. So one after the other, it's like a step-by-step sequence, but in terms of objects and method calls. You can go to any level of details you want, or you can keep it at a very high level. This is a very simple example of what a sequence diagram may look like. I'll take the example of the video rental thing that I was talking about earlier. I am a customer. I am going and want to rent a video. So the counter staff will enter the film number, which will be validated by the system. Then counter staff will enter my customer ID, which will again be validated in the system whether I am a valid customer or not. Then I will select the payment method and make the payment. So very simple, 1, 2, 3, 4 interaction between counter staff and system. Done. But this is not really helping. It's not really explaining what exactly is going on within the system. So I can get into more details. The counter staff makes a request for a loan, so on behalf of the customer, of course. So there is a loan object in the system. Loan is an object of a class called loan. So there is a method which is entered, and then which goes and checks the availability of the film, whether the film is available in stock or not. Then enters the customer number, and it goes and checks whether it's a valid customer or not, gets the details, checks whether if the customer has any pending dues, so whether the customer has taken a video earlier and not returned in, or not paid any fines and so on. It checks all that. If everything is okay, then it broadcasts a fee, that is, shows the fee to the customer, and then a payment is done, and everything is done. So you can get into more details, as many details as you want in a sequence diagram. Another sequence diagram that shows much more interactions of this is for the CD and the sales report that I showed you earlier in the class diagram. So it shows you an interaction between various components of the CD sales system, if I can call it. So it makes certain calls between objects, they return some, and that's how you depict the flow of a system in technical terms using a sequence diagram. So let's switch to Visio again and take a look at how to go about creating sequence diagrams and see how useful they can be. Okay, so now let's take a look at sequence diagram. I'll create one more page here. And I'll have it as a sequence diagram. So now in sequence diagram, first of all you drag and drop an object lifeline. It's called an object lifeline, indicating how long is this object going to be active in the whole process. Every object, every component that participates in the process will have to be represented on the sequence diagram. So let's say even an actor is an object. So let's call him customer. Okay, created a customer, because it all starts from the customer, and on a login form, and there will be actually I will call it customer actor, and this is actually the customer class. customer business logic layer, customer data access layer. Okay, some objects that will participate in this process of login. So the first thing that will happen is the customer actor will get onto the website and put in some information on the login form, that is username and password, and click on submit to login. So the first message that will be done is, it's not actually a method call, but it's just some message that is being passed called enter username and password. Okay, once it is entered, clicks on submit. The moment clicks on login, okay, what will happen is on the login form it will create a new object of the customer class, okay, and then create a new customer object, and then it will say get customer details by passing it the customer username and password. So that's what it will do. So what this will do is it will then contact the data access layer saying get customer details. Now I'm not going to provide any further interaction because the customer dial then connects to the database and fetches the data, so I'm not going to represent the data here itself. So assuming it found it, it will then return customer details to the business layer, which will and then this will validate user, whether it's a valid user or not, and then return back to the form indicating the customer details, whether it is valid, not valid, and whatever. And once it comes back, it will then redirect to the next home page. Let's say home page. Let me call it home page. So after logging in, it will load the home page. So that's how sequence diagram is created. You represent each and every object or component that participates in a process, in a functionality, feature, whatever you want to call it, and then step by step indicate what is happening in what order. For example, here the user first enters the user ID, password, clicks on login. When you click on login on the form, it creates an object of type customer, takes that and passes it to the BLL, calling the method get customer details, which then connects to the DAL, which will further connect to the database and fetch the data. Once it is fetched, it will return that customer data, which will then be validated by the DAL, whether it's a valid user or not, and depending on that information will go back to the form, and then it will redirect to the home page. So now this is all fine if it's a valid user. What if it is not a valid user? So in that case, what you do is you take the message call, which is the self message call here, okay, and increase the size of this and put in a condition saying if validated. So if the user is validated or not. So if it is validated, you go here, correct, and else you go to an error page. So if valid, go to the home page. If not, then load the error page. That's how basically you create sequence diagrams. Okay, and you can specify conditions like this, or you can put in a note somewhere saying, if validated, then it calls load, or if not, then it calls error page, and so on and so forth. So basically you try to put out as much detail as possible to explain what are the different components doing within a given use case or given process, and how do they interact with each other, what method is called, what is returned back. That's what a sequence diagram is all about. Okay, state chart diagram. We've looked at use case diagram, class diagram, and sequence diagram. The next one is state chart diagram. Now what can happen is every class in the system can have different states. For example, a document or a request for a leave can go through different states. One is created. So if I am an employee and I want to go on leave, I will have to put in a request which will then be either approved or rejected by my manager. So I will put in a request, so it is in created state. Then it goes to the manager and he picks it up for review. So it goes into in progress state. Then the manager may either accept it or reject it. If it is rejected, a reason is provided and the request is closed. If it is accepted, then again it is accepted and the ticket is closed, saying okay, accepted, done. So that's where it goes. So it can go through different states: created, in progress, accepted or rejected, and if it rejected, some reason will be provided, and then closed. So it goes through different stages. So state chart diagram is used to model these different states that a class can be in. So and it also depicts how this class transitions from one state to another. This is a sample state chart diagram that you can see, where each of these boxes that you see are the states in which a system is currently, and then based on certain conditions and events, it moves from one state to the other. Okay. So basically it's based on certain conditions and events, it can move from one state to the other. Basically explains a loan process where a loan application is given and then it will be verified, and then probably it is rejected, or it goes for approval, and then after approval it goes for processing and loan is given out, and so on. So it goes through different stages. So on what conditions, on what basis it will move from one state to the other, all that is explained using a state chart diagram. So let's switch back to Visio again, and let's see how a state chart diagram can be created in UML. Alright, so next up is state chart diagram. So what I'll do is I'll add a new drawing here. and go to state chart. So state chart diagram is used to represent transition of state of a class from one state to the other. There will always be an initial state from where it will start. Okay. Then there could be another state where it goes through. So let's take a loan application. Okay. It says applied. The loan has been applied for. Then someone will check whether papers proper or not. Okay. Just reduce this to 8 points. Okay. So it comes from here to here, and so it kind of comes here. Now the outcome can be either a yes or a no. Are the papers in order or not? If yes, then it goes to another state where it will be waiting or in queue. Okay. Or it could be rejected. So could be rejected, or could then if everything is in order, then it goes into queue. If not, then it is rejected. If it is rejected, it could go back to the user who will make changes and then put it back into the application. So I can say amend and resubmit. Okay. So that can happen. Now once it is in queue, after it is in queue, it will be picked up by someone in the bank who will process it. So once it is picked up, it will be in process. After it is in progress, people will evaluate it and so on and so forth. Put in some rules. I'll call it eligible. Okay. And out of this, it can either be approved or it can be rejected. So on. So this is how you would create a state chart diagram. And once it is either approved or rejected, it becomes the final state. and that's where the flow ends. So this is the state chart diagram of a loan, where first it is applied, then the papers are validated. If the papers are not in proper order, then it gets rejected, sent back to the customer, who has to amend the papers, provide more papers or something, and resubmit. Then if everything is in order, then it goes into a queue where someone will pick it up for processing, so it becomes in progress. Once it is in progress, someone will validate all the papers and credibility and this and that and eligibility and all. If it is not eligible, it is rejected, case closed. If it is eligible, then case is approved, disbursement made, we can go on, and then comes to an end. So this is a state diagram which explains the workflow of a loan application. Of course, there can be more after this, that once it is approved, there will be disbursement of the loan, and then EMI being given and full payment being received, and then the loan actually being closed. So that can become a separate state chart diagram to explain what happens after a loan has been approved. So it will become a separate process, and a separate state chart diagram can be created for this. This is only for the application part, not the full end-to-end loan cycle. So that's a state chart diagram. Then there is activity diagram. This is very similar to flowchart diagram that you may have used earlier. Very similar, not much difference. It's just that there are some additional notations available in activity diagram to explain things even much more clearly and in a more detailed manner. So it basically shows the procedural, the full flow of the system, very similar to, like I said, a flowchart diagram. It also can be used in place of a state chart diagram to explain how a class transitions from one state to the other. But if there is such a situation where you want to decide between which UML diagram to use, whether an activity diagram or a state chart diagram, the decision is simple. If it is explaining or depicting the transition of a class from one state to the other, then use a state chart diagram. If you are explaining the flow of the system, a flow of the feature or an activity, then use the activity diagram. Some symbols that you can use in activity diagram, you will notice that quite a few of these are very similar to flowchart. There is a start point, an end point, an activity, a synchronization bar, and a decision activity. Sync bar, we'll see what this is. Basically, when you split into multiples, or there are parallel things to be done, or a fork happens and then there is a join back from the fork and so on. That's where you use a synchronization bar. A simple activity diagram here. One thing you will notice here that is different from flowcharts is, it has two sections to it, one on the left and one on the right. This is used to represent different entities within the system. So one could be the system, one class, and the other could be another class within the system, where it is passing information from one to the other, and that's how the flow happens and so on. Or maybe you are depicting interaction between two different departments or two different modules, and one part is done by one module, then it takes it, gives it to the other, it does something, gives it back, it does something, gives it back, and so on and so forth. That's how you represent activities. And these individual columns that you see that are created, these are known as swim lanes. So each swim lane belongs to one component, module, class, or whatever is the level of diagram that you are creating. But the flow is very much similar to how you use flowcharts. So let's again switch to Visio, and let's see how we can create an activity diagram using Visio. Alright, so now for the next UML diagram, which is activity diagram, the last on the list. So let me go ahead and create a new page. And I'll switch to activity. So I had mentioned this earlier that this is very similar to a flowchart, quite similar actually. But there's one difference where there is a concept of swim lanes over here. So what you can do is you can put in swim lanes here. Different swim lanes. Let's go with only 2 right now. and say customer and system. Okay, it always starts from an initial state, which will be the customer. Action would be search products. Okay, now what will happen is when a product is being searched, what the system will do is fetch products and display products. Alright, so control flow will be from here, it comes here, from search products, goes to the system, and from here, once it finds the products, it will display the products. Now, once it displays the products, customer says add to cart. So what the system will do is add item to cart and so on. Okay. Then at the end, customer will say possibly comes back here, or rather wait, I'll just create this line again. This will be display cart, and once a cart is displayed, the customer says okay, place an order. So customer says place order or confirm order, whatever. Once that is done, what the system will do is do some validations, check inventory, is the product that is being ordered in stock or not. If it is not in stock, display error. If it is in stock, validate credit card. If it is not valid, again display error. And of course, and if it is valid, then place order and show a confirmation. Show an invoice and end it there. Okay, I'll just connect all the dots here. From display cart, it goes to confirm order, and then checks for inventory. After inventory, it displays checks whether it is in inventory stock or not. If it is not in stock, display an error. If it is in stock, validate the credit card. If it is a valid, then place an order and generate and show the invoice and end the flow. If the credit card is not valid, display an error message. So this is how you build activity diagrams. You could have final states here and here. Okay, so you can put more than one final end states here. You will have only one starting point, but you can have multiple endpoints. The reason I did not put endpoints here earlier is because if inventory is less, then I display an error, but then I allow the customer to search for another product and place it in the cart, and so you can build all that in. So you would actually redirect from here, from display error, and bring it back to search, and the whole cycle continues again. So you could do that, but that will take too much of time, but you get the idea how everything works. So this is how you can create activity diagrams and explain how different components or actors or systems, even systems, two different systems can interact with each other, and you can show that using a activity diagram, and this is how it is done. So this is activity diagram, very much like a flowchart. It's just that you get a facility of showing swim lanes here, which makes things much more clearer than what would be represented on a flowchart. So these were some UML diagrams that you use in your day-to-day life. There are quite a few others, but those are not that often used, very rarely. These are something that you will come across and have to understand or create more often than not. So these were UML diagrams. Use case diagram, class diagram, sequence diagram, state chart diagram, and activity diagram. So now some MCQs on UML. Question 1. In a class diagram, which notation is used to depict the public method? So if a class has a public method, how will it be represented in a class diagram? So option A is asterisk, B is plus, C is caret symbol, and D is ampersand. So which one of these is used to represent a public method? The answer is B, a plus sign. Plus represents public, minus represents private. Question 2. In a class diagram, again, which notation is used to depict a aggregate relationship? We've talked about aggregate earlier. It's an association between two classes, and aggregate is a special type. There are three kinds of associations: a normal association, an aggregate, and a composition. So which notation is used to represent a aggregate relation between two classes? Option A, solid line with empty diamond at container. Option B, solid line with filled diamond at container. Solid line with empty arrow at container, and solid line with filled arrow at container. Which of these? The answer is it's a solid line with an empty diamond at the container. The difference between option A and C is that we're talking about an empty diamond and an empty arrow. Empty arrow is not to be used to depict aggregate or composition. An empty arrow is used to, basically an arrow is used to depict inheritance, not aggregate or composition. Question 3. In a use case diagram, how do you depict a condition? A, using a diamond, B, using a rectangle, C, using a square, or D, you cannot show conditions in a use case diagram. Well, you should know by now that in a use case you cannot depict conditions at all. It's basically a use case diagram is used to represent each individual functionality or feature of the system and which actor is interacting with use case. You are not getting into the details of each use case, saying how it works and what are the different things that are going on in that use case. You're basically having one diagram which will have many use cases and how do actors interact with each other. So you cannot actually depict conditions in a use case diagram. Question 4. A condition can have which of the following outputs? A yes, no, maybe, all of them, or none of them. So if I have a condition, what can be the possible outputs on a UML diagram? And this UML basically means on a activity diagram. Okay. Obviously, the answer is it can either be a yes or it can be a no. There is no such thing as a maybe in a program. A computer program cannot work on maybe. It has to be either a yes or a no. Question 5. In a sequence diagram, how do you depict a return from a method? So there is one object which makes a call to another object, that is passes a message or makes a method call. That other object is doing something, and returning some value back to the caller. So how do you represent this return value on a sequence diagram? Option A, using a solid line. B, using a dashed line. C, using a solid line with a filled diamond. And C, using a dashed line with an empty diamond. The answer is B, using a dashed line. A dashed line, you use a dashed line indicating it is returning a value, and if it's a dashed line, it means it's a return value. If it's a method call, it's a solid line. There is no empty diamond or any kind of diamond used in a sequence diagram. Question 6. What does UML stand for? United Modeling Language, okay, United Medieval Language, Unified Modeling Language, or Unified Medieval Language? You should know this answer. If you don't, then you might as well go back to slide 1 and start all over again. It is Unified Modeling Language. Question 7. Which of the following are not true for a class diagram? Please note, it's a negative question. It's asking for what is not true. Which of the following are not applicable to a class diagram? Option A, shows relationship between entities. Option B, shows relationship between use cases. C, shows relationship between objects, and D is none of the above. Obviously, I have not put all of the above because there is no single diagram which shows all of these. So the answer is a class diagram shows relationship between entities. Relationship between use cases it shows using use case diagram, and the relationship between objects is showed using sequence diagram. So which of the following are not true for a sequence diagram? A, shows the state transition of a class, shows the relationship between use cases, shows sequence of messages between objects, and none of the above. So again here, since we're talking about sequence diagram, the name itself suggests it is showing the flow sequence of of how a process works. It's actually the right answer is C, shows the sequence of messages between objects. Okay. Question 9. In a state chart diagram, we must use a swim lane, true or false. So if we're explaining how a class transitions from one state to the other, then this whole transition should be shown using swim lane. True or false? False, of course. State chart diagram has no such concept as swim lane. A swim lane is used in which diagram? So if it is not used in a state chart diagram, where is it used? In a class diagram, sequence diagram, state chart, use case, or activity? Obviously, it is used in a activity diagram to represent different sections of a system and what each of those systems is doing, so it can keep passing between different swim lanes. Question 11. In a state chart diagram, a class can have many end states. True or false? What this means is that a class, possibly when its transition ends, there is a possibility that the end state of a class can be one of many, so it can either be in one state or the other, and so on. Can that happen? Can we do that? Well, very much it is possible, because the example that we took about a leave application, finally the application will either be accepted or rejected, correct? So it can have more than one state. Okay. Question 12. Conditions in an activity diagram are depicted using which of the following notations? An oval, a square, a diamond, or a question mark? It is represented using a diamond. This is the standard notation even without UML. So if you use flowchart, even there a diamond is depicted on a flowchart to show a condition. If some condition, if age greater than or equal to 18, then allowed to vote, and so on and so forth. So a diamond is used to represent a condition on an activity diagram also. Question 13. You can depict multiple actors on a use case diagram. True or false? Of course, this is true, because you will be showing a system boundary with many use cases, and each of the use cases may be accessible by one or more actors. So obviously you can depict more than one actors on a use case diagram. Question 14, how do you depict a many-to-many relationship on a class diagram? So if you have a class diagram and you want to depict a many-to-many relationship, many-to-many association, which notation would you use? 1 to star, star to 1, star to star, or n to m. Star represents many, so it is obviously answer C. Answer is C, star hyphen star. That is many to many. And final question, question number 15. On a class diagram, which notation is used to depict interface implementation? We spoke about object-oriented concepts where a class can inherit from another class or a class can implement an interface. For inheritance, we've seen, so is it A, solid line with arrow at the base class, or B, solid line with an arrow at the derived class, C, dashed line with an arrow at the base class, or D, dashed line with an arrow at the derived class? So which of these? It is C, dashed line with an arrow at the base class. Option A is the one that is used to depict inheritance, a solid line with an arrow at the base class. You cannot have a solid line with an arrow at the derived class. You can't do that. If you do that, then the derived class becomes the base class, so that is wrong. And option D is, again, you cannot have an arrow pointing towards the derived class, so that itself rules out B and D. And a solid line is used to represent inheritance. A dotted dashed line is used to represent implementation of interface. So those were MCQs, sample MCQs that you can expect many such MCQs in the final exam. And these are some reference URLs that you can use to know more about UML, some videos, some articles, some PDFs, and so on and so forth. So go ahead and try these reference URLs and get to learn more about UML. Thank you very much.